Welcome to Bug Banter with the Xerces Society, where we explore the world of invertebrates and discover how to help these extraordinary animals. If you want to support our work, go to xerces.org/donate. Hi, I'm Matthew Shepard in Portland, Oregon.
And I'm Rachel Dunham in Missoula, Montana. We are at a month into the new year and have started a new season. We wanted to take a minute to thank all of our listeners. We are happy to report that we are in the top 5% of podcasts.
Woohoo!
So thank you for making that possible. We look forward to another great year of bantering about bugs.
Yeah, no, I just want to add my thanks for everybody who listens out there too, because without you, we would just be, a group of people sitting around having a conversation. But the fact that you're listening and enjoying and listening again and again and again is just fantastic. So thank you. So to get back to today's business, the monarch butterfly is popular and currently in the news a lot. And you might think we already know all there is to know about it, but that there are many mysteries remaining, particularly about their migration and how they use their habitat. This may be more so for the Western population that overwinters in California. And radio tracking has long been used for studying the movement and habitat use of bigger animals. Advances in this technology mean that it's now emerging as a tool that can provide scientists with some answers about tiny animals too. And to explore how radio tracking, which is also called radio telemetry, can be used with monarchs, we're joined today by Ashley Fisher. Ashley is an endangered species conservation biologist and monarch overwintering specialist with the Xerces Society. Based near the overwintering sites in California, Ashley manages Xerces' overwintering habitat database and helps facilitate research projects, working with Xerces' partner organizations and universities. She also works with local land managers and communities along the central coast of California to provide guidance on the management and restoration of overwintering sites. Welcome to Bug Banter, Ashley.
Hi, thank you guys so much for having me.
Yeah, we're excited to have you. So to start, can you tell us what radio tracking is? How does it work?
Yeah, so radio tracking or radio telemetry, like you mentioned, is basically a method that scientists use to track individual animals as they move through their habitat. So, with birds and deer and just other wildlife, it can be super useful to understand how animals interact with and use their habitat. But it's not really easy or practical to try and like sneakily follow them around in person for weeks at a time. So this is just a really good way for us to actually do that in a practical way. And while there's other kinds of tracking that's often used for larger animals like GPS tagging, GPS tagging is where you tag animals with a device that can send out the exact latitude and longitude of an animal, and it's generally used as like a collar wrapped around their neck, as an example. These are really, really cool because they can give you that exact location, but all that hardware and all that energy going towards sending off those locations on a daily basis requires a really big battery. And for that reason, we can't really use GPS tracking for really small animals. So we actually turn to radio tagging. Radio tags basically require a lot less hardware and generally less power to release their little radio tag signals. So it's basically perfect for things that are flying and like birds, bats, and even monarchs now, which is pretty cool. That really need to be a lot smaller to be able to move throughout their environment. So what we do is we attach these tags, or transmitters as they're sometimes called, onto individual animals. And then these little tags send out pulses of radio waves or magnetic waves into their surrounding environment. And what's cool is that they'll ping, every second or every couple of seconds. So once we release these animals into environment, we can use special devices called receivers to detect these signal pulses in the wild and figure out where they are as we watch them move through their environment through time. And receivers are basically radios tuned to the specific frequency that these tags are releasing their little pings at. And so you're basically having like a little radio that's listening for any of these tags that are are around you. And if they're pinging within your range, it'll basically tell you the individual tag's ID, which is normally a number, but you could be like, oh yeah, that's Carl. Carl's over here. And then it'll tell you how strong the signal is, which can kind of tell you how close or how far, or if you're pointing in the right direction or not you are to the individual animal.
Oh, that's so interesting. That's so cool that technology can do that. My husband had the opportunity to do some of this work with wolves in Yellowstone. And
oh my gosh.
Yeah, luckily we don't live that far from Yellowstone. So we go back frequently and he's always talking about what it was like. But even just how difficult it is for big animals trying to figure out where these wolf packs are and hiking around in the snow and trying to listen to signals. So I sort of have this image, but for these tiny animals, it's incredible that we can do that for butterflies. So you talked about the receiver and mentioned that receivers are able to hear the pings from tagged butterflies. Are they equally as small and easy for people to carry around?
Yeah, great question. So there's like two kinds of receivers, I would say generally that researchers used. There's the handheld ones, kind of like the ones that your husband used, awesome, on wolves. And then there's basically like towers or stations. So it's basically, can you move around with it as a like a person that can carry it? A lot of times they look like little purses, which is kind of cute. And then, or do you want like a station that basically called stations because they're stationary. So handheld ones are basically like handheld radios, like I mentioned, and then they have antennas that you sweep through the air, basically, almost like a metal detector. If like you picked up a metal detector where you sweep back and forth, but you're just doing it in the air in front of you. And you can wander around the landscape basically waving these what you'd call directional antenna, looking at the tag signal strength to kind of see whether you're getting closer or further, or you're pointing in the right direction, which kind of gives you a better idea of where you are relative to the animal and hopefully like triangulate where it is. And then if you do get eyes on it, you can get exact coordinates if that's a goal of your study project. But the other kind of receiver, like I mentioned, is those stations are stationary. They're also called remote or automated telemetry stations, and it's basically a radio tower. And what's cool about these is that they can always be listening for the radio signals. And just like radio towers, you're just basically putting them up in areas with really good visibility in all the different directions. And then you'd have, 3 to 4 antennas pointing in all the different directions to kind of get all the coverage around that area. And so if an animal, if it's collar or like a bigger animal, if they walk by or if they fly by as a bat or a monarch, you can kind of get them as they pass through. And one of the biggest strengths for using these remote towers is the fact that they can be on 24/7, which is really, really awesome because, depending on what you're studying, monarchs only move really during the day, but if you have like nocturnal animals, you can still, potentially pick those up if they're battery powered. And the way that they do this is because they also actually have cellular capabilities too. So they can basically send that data off in real time to us.
Oh, that's very cool. I imagine for migratory species, it's especially helpful because they are really on the move. Is this unique? I mean, you mentioned birds and bats, so it's not just unique to monarchs that they're using this radio telemetry with towers.
No, and totally, like you mentioned, I think how these remote stations are used is definitely probably most popular with people studying migratory birds at this time. And now everyone else that studies migratory things, and I've even seen it with dragonflies now, but dragonflies, bats, really small birds, like even smaller birds, people are getting really interested in getting more of these remote stations on the landscape so they can kind of catch them as they move through their migratory habitat.
Yeah, it's amazing what technology can enable us to do these days.
Yeah.
You mentioned some of the good things about this, but there must be some challenges with this or disadvantages of the different systems.
Yeah, totally. So like remote towers, I'm talking about how awesome they are, but they're pretty expensive. They're like at least $10,000 to set up, and you have to also maintain them. A strong windstorm comes in, it's going to knock it down. And if you're putting it often in like these remote areas, that's kind of a pain in the butt to go out there every time, so you want to make sure you're putting it together really sturdily and it can stand up the test of time, because you want it to be like fully remote a lot of the time. You can plug it in and put them on top of buildings, which is really cool. But, like I mentioned, often these are in wild areas tracking wild animals. So because of that, they have to have their own power station, which means that then you have to have a solar panel and then a charge controller and the battery. So it's controlling the power flow into the computer station that detects and processes it. So like it can get complicated really fast. And as a biologist, I'm at my max of like my 1 year of physics I took, or like 2 years of physics I took, like when I was learning how to do this. So they're more complicated, but they can get you 24/7 monitoring, which is really cool. Yeah. On top of that, just like, unlike GPS, monarchs or like any tagged individual, they have to fly within range depending on the frequency your tag is functioning at. That basically just means they're within a kilometer or 14 kilometers of your tower. That's not giving you like an exact location. It's still really useful, but that's basically just the limitation of using these remote towers. And so depending on the question, handheld telemetry can be a lot easier. And those handheld receivers where you're wandering around, like holding a purse, waving it around like a metal detector, these can be a lot easier to use. And you can basically move around and use them to get, eyes on your tagged animal and therefore get a more accurate location. So for example, they used radio tracking to hunt down the northern giant hornet's nests that were not native in Washington state. So I thought that was a really, really cool application also with insects, where they could tag one and follow it back to the hive to figure out where that hive was, or nest. But yeah.
Yeah, no, it seems like some of those challenges are well worth overcoming.
Yeah.
For the data that you can get from this. And again, I mean, you mentioned the giant northern wasps, and how they're being used there. I mean, are there any challenges kind of unique to monarchs and the work that you're doing with them?
Yeah. So we have new tags that are small enough that fit on them.
Mhm.
And I think that is where we're really, really thankful that the radio tag technology has come such a long way. And I think the two lightest tags, the previous version that people had been using with monarchs, other researchers, was a tag from the low-tech brand, and it weighed 0.13 grams. There's some that were even heavier, but they've gotten lighter since then. Um, and that's great, but monarchs weigh less than a gram, and a gram is about the weight of a paperclip. So it's kind of crazy that they can even make the migration being that tiny. But then also putting something on them, we're very concerned about the potential detrimental effects it has on them, even though there's really good implications for conservation when you can better understand how they use their habitat. We want to be really, really careful about that, and have a really good reason to tag them. And that's really important when we come up with our research questions in these study designs. But there is a new tag on the market that we're most interested in, and a lot of other researchers that I collaborate with are interested in. And it's called the Blue Morpho tag, and it's from Cellular Tracking Technologies. And this is really, really exciting because they only weigh 0.06 grams, which is super, super tiny. And the reason they can get it this tiny is because it has no battery. It just is a solar panel attached to all the hardware that then releases the signal. So it has no battery, which makes it a lot lower percentage of their body weight, which, we don't want to tag any more monarchs than we have to, but it's still really nice to know that we can get it as small as that and still be able to track monarchs. Yeah.
Yeah, I was thinking about that, and the weight that you mentioned, 0.06 grams, is like about the weight of a grain of rice. Also, that weight comparison, I was thinking a little bit about that. It's like, for me, if I had to pick up and carry 5 quarts of milk,
You wouldn't want to tote that milk around 24/7. Like it's
no,
still not something we really want to do, but it's a lot better than what it could be. So
yeah, totally. No, it's way cool.
yeah. But there's some differences between this tag and a lot of the other tags that have
Mhm.
typically been used. It's actually on on a new frequency. So there are normally tags that are used in the US and Canada. They function at 166 megahertz or 434 megahertz. These ones are at 2.4 gigahertz. So it's like ultra high frequency. But what's really, really cool about this is that that's actually the Bluetooth frequency, and every one of our phones can actually have the power to detect these tags because of that. And so Cellular Tracking Technologies, or CTT, the company that makes these tags, and Cape May Science Center, they partnered together. Shout out to Sean Bircher at Cape May. And they developed this phone app that basically anyone can download if they're in a research area, and potentially collect monarch detections on the app as they like walk through, say, an overwintering site, which is super exciting for potential interactions with citizen scientists and them being able to contribute data.
Yeah, no, it's again, how many times will I say this? Like, wow, isn't technology amazing?
It's crazy.
Yeah, to have something so small and now it connects with this amazing piece of technology that so many of us carry around, um, it's great. I mean, how do you attach one of these to a monarch?
Yeah, that's a great question. And it's we have basically like a monarch tagging like working group that we help facilitate, where everyone can come together. And there's a lot of researchers like thinking about this and coming up with best practices, which I'm really, really thankful for. But basically, with each monarch, we gently cover their wings. We're like holding them by their like thorax abdomen, and then we cover each of their wings with these things called glassine envelopes, which are basically just like parchment paper envelopes. And this protects their scales from rubbing off or their wings getting caught on anything. And then next, we have to very carefully lay them down and open their wings up. And then as their wings are open, we actually glue the tag on the to the top of their thorax, which is basically like between our shoulder blades, almost like at the base of our neck. That's the equivalent location, if you can imagine that. And we use duo active eyelash glue. That has been shown to be like one of the better glues. So it's the first time I've ever bought eyelash glue in my life, was for tagging monarchs. Um, yeah, which is great. And that's how we basically get them on top. And before, with different tags that were battery powered, we were thinking about putting them on their abdomen, but we actually have to put them on the top with these blue morpho tags because they're solar powered, so they have to have access to that sunlight. So that actually dictated some of those decisions. But we've been really, really lucky to learn a lot from Lee Brown and her grad student, Helen St. James at James Madison University. They have done the most tagging so far and came up with a lot of these techniques, and we've learned a ton from them. So I just wanted to shout them out. And they actually did a greenhouse experiment comparing the effect of different glues to attach the radio tags. And then they tracked kind of the monarch survivorship through time, because we were still worried about like what glues are safe, what glues are not safe to use on monarchs. And they're still analyzing the data, and this hasn't been published yet, but they're pretty certain that the duo active eyelash glue and Turbot, I think, are the best options. And crazy glue and other similar sorts of glues to that should probably be avoided because they might be toxic. So people are thinking deeply about this, and I'm really, really thankful that they're doing this work. It's not public, that's not published yet, but I got the okay to share that
Yeah.
because they've been great collaborators. Yeah.
No, it's always reassuring when people are thinking so carefully about it, because obviously, you know, monarch is such a delicate animal,
Yeah.
although more robust than we think. You see a butterfly and you go, oh, how beautiful and delicate and gentle, but
Yes.
it's this thing that's strong enough to fly hundreds, thousands of miles.
Yeah.
Still treat with care. I'm thinking about treating them with care. I mean, how do you catch the monarchs in order to hold the wings in the glassine envelopes and stick it on?
Yeah. Also a really good question. I feel like I'm cheating because our colleagues on the East Coast, like Lee and Helen, uh, if you're doing this with like summer monarchs or monarchs when it's warm outside, like individuals, uh, they aren't as lucky. They actually have to chase them when they're really warm and very, very fast. I totally cheat because I work on overwintering monarchs. So what they do is they cluster together in these trees in the winter, as a lot of people might know, but they can't fly below 55 degrees Fahrenheit. So what we do is we know where they are, we know where they're clustering, and then we get there really early in the morning before it gets warm. So yeah, we basically cheat. But then we take basically a big long net, like a big butterfly net, and then it's attached to like a telescoping pole. Sometimes we need ladders to get to the cluster, and then we pick a really, really small cluster because we don't want to disturb a lot of monarchs. And then we gently shake them into our butterfly net, and then we store them, sometimes even in a cooler to keep them cool, until we process each of them, and we weigh them and make sure they're big enough to get tagged and do all that stuff.
And once you've tagged them, does that tag affect the monarch's ability to fly away? I mean, because it's always that challenge that when you want to study something, is your study interfering with or changing their behaviors?
Totally, totally. And we know for sure that in any circumstance, we know that what we're doing is going to probably affect how they're interacting or the behavior a little bit. But we do know for sure, especially with these blue morpho tags, and even some of the other heavier tags, actually for sure with them as well, they can fly with them on. And other studies have shown, like some tagged monarchs have been redetected quite like hundreds of kilometers away from their original tagged area. So we know that they can fly, and it would be pretty evident if they couldn't that we probably shouldn't be using some brands of tags. But what to degree affects the behavior and how long they can fly on average is also an active area of research right now, especially with Lee Brown and Helen at JMU looking into this. In one of their recent experiments, they actually followed around some monarchs that had CTT blue morpho tags on them to look at the effects on their movement patterns in like the short term. And these results also haven't been fully analyzed, but it looks like preliminary results show that there's not a significant effect, at least on the short term movements, at least with the blue morphos. Of course, on some level, we're gluing a backpack onto someone. It's like if we force someone to carry a backpack around all the time, we know it's not amazing for them, but having it show that at least in short term they can still go about their day normally is really encouraging. But we do think about that a lot before we choose to design these experiments and tag them and get the permits to do so.
I appreciate that, like Matthew had said, you said just how much care is being put into this. Yeah. So
Totally.
You work particularly with Western monarchs in their habitat. How are Western monarchs different from the Eastern monarchs?
Yeah, that's a great question. So like the North American population of monarchs, we just generally, when we talk about it, divide them like by the Rocky Mountains into East and West. But they do intermix a bit. So it's more of just like a geographic situation. But both spend summers breeding on milkweed around the United States, and they have that migratory generation in the fall that makes that long journey south. But generally, the eastern population is way bigger, and they're the ones that basically migrate to Mexico into those really, really big overwintering sites that you see a lot of footage of, where they're everywhere. They're covering the trees. They measure them in orders of like amount of acres that they're covering because there's just so many of them. There's millions. In contrast, on the west, the population in general is a lot smaller, and they actually overwinter on the coast of California in these coastal tree groves. And there's actually hundreds of overwintering sites where they're a lot more spread out, basically. So at an overwintering site, you can see anywhere from like a couple dozen to only up to 30,000 monarchs, which is just on the scale of the eastern population, just a lot smaller, but there's just a lot more overwintering sites. And so we don't see clustering together in the order of the millions, but it's really interesting. Like the dynamics are a little different because they do move between these overwintering sites, and we don't really understand the exact timing of when these movements happen.
I still can't even imagine. I've never gone to an overwintering site, so even 30,000, I'm like, oh my goodness, that's so many to see
Yes.
in one area. I mean, I grew up in the outside of Portland and being in Montana now, and all the states I've lived in, I've actually never really lived anywhere where there were an abundance of monarchs. So I've seen
Totally.
like one or two individuals my entire life. So seeing thousands together is kind of mind blowing.
I'm not gonna lie. There's this thing when you're in an overwintering site, when it gets really warm, sometimes there's this thing that happens that calls a cluster burst. So like one monarch will come in and it bothers all of them, and it's warm enough that they all just kind of explode, and you feel like a Disney princess when there's hundreds flying all around you. You're like, I am in a Disney movie right now. I am the main character. So it's pretty incredible.
Yeah,
Love
no,
that.
we really need to get you to one of those sites, Rachel.
I
Yes,
know.
please
I will
come.
volunteer.
Please come.
No, it sounds wonderful. I love that you said that actually, because on a previous episode, I had talked about an experience that I had with the California tortoiseshell butterflies in
Oh,
Central Oregon when they were migrating. And I said the
yes.
same thing. I was like, I felt like a Disney princess. They were
Yes.
flying everywhere around me. It was such a special experience, but it's just incredible how these tiny, beautiful animals can touch our hearts and inspire us. That's just really amazing.
Totally.
So we've talked a lot about radio tracking, how it works, how you get the monarchs, how you attach this tiny little tracker. But how does the data from radio tracking help Western monarchs in particular? Is this essential to their conservation? Why are we doing this work?
So, yeah, despite monarchs probably being one of the better studied insects of North America, there's so much we don't know about them, and this is especially true in the West, where they're not studied as closely, and we don't really know a lot of the major migratory routes. I think some of the number one questions are, the population arrives in October, but we're not really sure about their migratory routes here. Like identifying key migratory routes would be a huge uh, way that we could concentrate our efforts for conserving their habitat where it matters most. Also, we know that they're here roughly between October and February, but we're not really clear where they go afterwards. Like that first generation, it's not clear how long it takes them or how it takes them to go inland, where they're going inland, how far they're going inland, how fast they can travel back to the milkweed areas, which kind of determines like where the critical habitat should be for that first generation that's coming out of overwintering season. And then third, and like the one that's closest to my heart because I study overwintering monarchs, is uh, you know, there's, like I mentioned, hundreds of overwintering sites. Some of them are close to each other. And we know that throughout the season, there's a lot of fluctuation in numbers between these overwintering sites. And we know that they leave overwintering sites for some unknown reasons. Some we know, some for some of the time we know that they go for nectar resources and water resources, but we also don't really know how far they're traveling. If they're coming back to the same overwintering site, we know that some move between overwintering sites. We just don't know how the population dynamics kind of exist in this network of overwintering habitat that occurs kind of piecemeal in these fragmented forests along the coast. So I think better understanding that would give us a lot more guidance of like what it means to have quality overwintering habitat. Where is their high fidelity versus like low fidelity, and they're abandoning these sites, certain sites, early in the season. Like, why are they doing that? So I think we stand to learn a lot about just tracking these individual animals and seeing how they're spending their time. People ask me a lot, like how many, like how much nectar should we provide, or like we're all wondering how far can you put nectar sources, or how much of a buffer zone do you need around an overwintering site with all these resources for that to be good? How much habitat do we need to set aside? And it's really hard to answer those questions without knowing how they use their habitat. And yeah, if anyone has ever tried to chase a butterfly, you lose them pretty darn quickly. They are a lot faster than me most of the time. So it's really nice to have these little tags to help us out.
Now that I have seen and I have tried, and it is hard.
I've whiffed quite a few.
Oh, anybody who's ever tried using a
Yeah.
butterfly net has done that, and we've all got tales of that embarrassment.
Oh
It's
yeah.
not. It's normally when you're doing an event and people are like, "Show us how it works," and you're
Oh
like
gosh.
sweeping and swiping, and
Yeah.
anyway.
Oh, I love the visuals I have right now.
Excellent.
Do you plan to use this technology in the future?
Yeah. So we have grant funding to look into this. That's where we learned a lot about these tags. I spent some time with um, Helen and some other research partners. We did some test tagging with these tags last year. Unfortunately, the populations were so low that we didn't feel comfortable doing tagging this last season because it just wasn't worth the risk to the population. But we do plan on tagging and tracking some overwintering monarchs to look at between site movement. And if those go well, another thing that we're working on with partners like California Department of Fish and Wildlife and other partners like Point Blue and Pat Lorch, we want to basically expand the network of stations that can pick up these tags around the state of California.
Is this technology used on eastern monarchs?
Yes, actually, so cellular tracking technologies is actually based in New Jersey. So they've done some work like testing at these tags and looking at resites further down the migratory pathway. There's also a lot of research that's come out of the like the Canada US border, although I think they're using low tech tags, which are, you know, pros and cons, but those are also effective. So they're definitely being used. I think the number one way that people are looking into eastern monarchs is to look at the rate and timing of the migration south. That's like the number one question they're looking at there.
Yeah, with some of, I mean, the eastern monarch migrates over greater distances, or even, I mean, even the western monarch from, you know, Idaho to California is hundreds of miles.
Totally.
I've heard about a nationwide network of tracking towers called MOTUS, which
Mhm.
I think was set up for birds primarily, or maybe elk. I'm not sure. I mean, and it's big and furry and feathered and got a backbone, so we don't really think about that.
Yeah.
But presumably that, I mean, that you must use similar technology of the telemetry. I mean, and I imagine that's also something that the monarch researchers might be able to tap into for if you could track a full migratory route.
Yes, totally. The Modus network is awesome, and it does use the same method, the telemetry. Those towers I was referring to, you know, the majority of the ones that are on the landscape are plugged in to Modus, which is basically just an interconnected set of radio towers. So it's a scientist that's like, hey, I put a radio tower up. I put these, you know, different radio antennas pointing in different directions to listen to all these different kinds of tags. I'm registering it on this website. So anyone that's tagged an animal with this recognized technology is going to get that data reported back to them, even if it's not from their tower. It can be from my tower too. So it's really cool. It's a bunch of people working together, and they're actually all over the world now, although there are some like blank spots. There's a lot of blank spots in California. And when we're talking about retrofitting towers, we're actually talking about retrofitting these Modus towers. So basically, we can bring monarchs into the fold and not just have it be, you know, used for bats and birds. And I think it's has a lot of potential for tracking a lot of different animals, which is really cool that everyone's coming together to create the network.
And also, as you were talking, I was remembering that you mentioned the possibility of a cell phone app.
Yes.
What role might that play in some of this long distance tracking? Because I mean, does it mean that if I have the app and my phone is on, that any passing monarch that happens to have a tag would show up on my screen?
Yeah, it's so cool and it's so exciting, but there are some limitations. So it's called Project Monarch, I think, and um it basically you have to have their app open and
Mhm.
scanning. You have to hit like a button that says scan. Um, so right now, unless you're living in an area that you know that there's like a research experiment going
Mhm.
on, like at Cape May Science Center where they've released tags, or there might be some stuff in the future in California when we're tracking overwintering sites. Um, you're probably not going to detect anything right now. It's really exciting though. Uh, for us, we want to look at inter-site movement between these overwintering sites where monarchs are clustering and spending the majority of their winter. I think when more research experiments you have to have a permit to do it, but a scientific collecting permit, just FYI, in California, when more of these experiments or a couple of these tags are released on monarchs during the winter, we have a lot of community scientists, and they go out and they count the populations or the local, at that overwintering site. When they go out, they could just turn the app on then, and they could basically be scanning for any of those tags. So even if they're outside of our radio network, our radio tower network, the citizen scientists have the opportunity to basically fill all those gaps while they're just going about their surveys, which is so cool.
Community scientists are cool and do help in huge ways. So yeah.
Yes, totally. It's really cool to just take it a little bit outside of the small group of people that are, involved in the radio tower stuff. That's frankly not really fun to set up, and just do the fun part where you get to take the monarchs.
And sometimes it's those unexpected observations that can add so much information.
Absolutely.
Yeah.
No, this is really exciting to hear more about this. I was so excited for this episode, just to hear from you, and look forward to seeing what we learn in the future going forward. So in the new year, we have added a new question. So we actually have 2 questions now for all of our guests. So I'm going to ask the new one. I get the honor and the pleasure today. And that is, if you could see any bug in the wild, and by the wild, I just mean outside of captivity, it could be in your backyard, that is still the wild. What bug, and you can use that term loosely as we are bug banter. We do talk about freshwater mussels on this podcast.
I love it.
Any invertebrate. What would it be if you could see any bug in the world?
Oh, man. It's a good question. I think I'm going to keep it local to my California, my California neighborhood. I've seen tarantula hawks a bunch of times before in the wild, but on my bucket list, I want to see, if listeners don't know, tarantula hawks, like they parasitize tarantulas. They will grab them, they paralyze them, they drag them back into their own burrow. I think you guys might want to fact check me on this. And then they lay all their babies into the tarantula, and then then they explode out of the tarantula while it's like still paralyzed. It is so metal. It's so hardcore. But what I want to see is a tarantula hawk with a tarantula. I've never seen it before. And that is like on my bucket list, because in October you start seeing the tarantulas. I'm like, it's going to happen. But that's on my bucket list for sure.
It's like a double bug hunt, isn't it?
It's a double bug. I went for double bug on my answer.
And for those who aren't quite sure, tarantula hawk is a species of wasp. It's a really big species of wasp.
They're huge.
It's one of the few that if you actually have them on your hand, it's an insect with a sense of weight to it, which is quite remarkable.
Thank you for explaining that, Matthew. I'll be honest, I had not heard of a tarantula hawk before, and I was imagining an actual hawk until you got to the whole parasitize point. Then I was like, okay, I must not be a bird. I'm probably going to cut this part out because it's embarrassing, but
no, don't cut it out. Because like, honestly, when someone said tarantula hawk the first time, I'm like, what are you talking about? And you could, if you saw one go by quickly, you might be like, that's a very small bird because they're giant.
Oh,
but they're
size.
Yeah, they're huge and actually like super iridescent and cool looking.
Oh yeah, no, they're really beautiful, yeah. Yeah, and our other question is like, how did you get to this point? And it's like, what led you to this? I mean, you're attaching tags to butterflies. I mean, was it a desire to study monarchs, or is it the technology that attracts you in?
I ask myself, how did I get to this point all the time? No, that's a great question. I went to grad school and I studied monarchs, but from the perspective of like learning how to do species distribution modeling. So it's like kind of coding and figuring out like heat maps, associations with their habitat to try to kind of better understand where they exist and where they might exist with climate change. But models can only take you so far. I'm so much of an applications person. And I think at the root of that was I'm fascinated and most interested in how the population dynamics are with monarch butterflies. It's so complicated because they can move so easily. And I think that is what drove me to be fascinated with the technology. And it's such a huge opportunity to answer the questions that I'm interested in. And I like figuring out, like, this is such a new application that's so exciting for me, even though I'm not that good at physics and I am learning a lot on the way. Yeah, power tools. Yeah.
I love it. I have to ask, what inspired you to study monarchs? Like, how did you even get to grad school to study these butterflies?
Yeah, I totally fell into it. I did an internship doing some honeybee stuff, and I started as a journalism major. So it's like a little left field. And I was like, oh, I want to be a science writer, but you have to understand science. So I switched into biology, and then I kind of fell in with a professor that happened to study monarch butterflies. Um, and that's how I got into species distribution modeling. I thought that was cool. I have a background in doing GIS works like mapping. Um, and I really like the applications part of it. But then I ended up learning a ton about monarch butterflies. I got really interested in like their thermal tolerances and all that stuff. And they ended up in my thesis that was way too long. And um, yeah, I think it's just I was in the right place at the right time. And one of the best things about butterflies, which isn't necessarily true, especially monarch butterflies, which isn't necessarily true about a lot of other invertebrates, is I love invertebrates. I love bees. They do such amazing ecosystem services that we absolutely need. But people love monarchs. And so they kind of understand it, and they can be a really good flagship for a lot of the other pollinators that maybe are slightly more unsung heroes. So I think that's the main advantage to monarch butterflies, and that's why I like studying them.
No, I think that's great. I love the meandering. We get that sometimes where people kind of are like, oh, here you are. I'll start studying you.
Yeah, totally. Yeah.
Yeah, but no, we're certainly grateful to have you at Xerces and lucky to
Oh,
have your expertise and your passion, and it definitely shines through in how you talk about your work. It's really incredible. So thank you so much for joining us today and answering a lot of questions
yeah.
about this technology. And hopefully in future years, when you use it, you can come back and talk about the data that you analyzed and that you found and what we've been learning. So
That would be excellent. Thank you guys so much for having me, Rachel and Matthew. It was lovely to talk about it and nerd out a little bit over bugs and radio waves, I guess.
Yeah, that's why we like doing bug banter, because we get to nerd out with people, which is just a great way to spend the time.
Yeah, you guys have an excellent job.
Thank you.
thank you. Bug Banter is brought to you by the Xerces Society, a donor-based nonprofit that is working to protect insects and other invertebrates, the life that sustains us. If you are already a donor, thank you so much. If you want to support our work, go to xerces.org/donate. For information about this podcast and for show notes, go to xerces.org/bugbanter.